Hello, physics loving friends. Today's topic of our discussion is the simulation based on Millikan's oil drop experiment. We abbreviated this Millikan oil drop experiment as MODE. So, this experiment has been performed by Millikan in the year 1909. The basic aim behind the performance of this experiment was to disprove Einstein's concept of photoelectric effect. For this, Millikan had tried to find the charge on ionized water droplets and he failed. After that, he thought of a plan to replace the ionized water droplets with eatable oil like mustard oil or any other eatable oil. And this simulation has been designed to make this experiment affordable or accessible for students of UG classes. So all the students have learned about this famous experiment. This basic experiment describes the quantization of the charge, meaning the charge on any charged body, total charge on any charged body is the integral multiple of the basic unit of charge, that is the charge of an electron. That means there should be integral number of electrons on a body, or less number of electrons or more number of electrons. If the number of electrons are in excess, the charge on the body is negative, and if the number of electrons on the body is positive, is less, then the charge on the body is positive. So the positive and negative nature of the charge of the body depends upon the number of electrons, excess or deficiency of the electrons. So this experiment, simulation is user friendly method to demonstrate the quantization of charge and the measurement of electrons charge and mass. So the brief introduction about Millikan. Robert Andrew Millikan was an American experimental physicist honored with the Nobel Prize for Physics in 1923 for the measurement of elementary electric charge and for his work on photoelectric effect. Millikan graduated from Oberlin College in the year 1891 and obtained his doctorate at Columbia University in the year 1895. So this year was the year of the invention of X-rays. So he also used the X-rays for his experiment. After the discovery of electron and calculation of the E by M ratio by J.J. Thomson in 1897, Millikan sought a way to measure the charge of an electron. After the measurement of charge, the electron's mass could also be calculated using the ratio E by M. He postulated that all electrons carried the same value of charge. In Millikan oil drop experiment, the charge of an oil drop measured repeatedly finally concluded that all oil drops possesses charge which is integral multiple of same quantity, and the same quantity is supposed to be the charge of an electron. So this is an approximate 1.6 10 raised to power minus 19 coulomb. So it is the charge of an electron. So what about the experimental setup? He used two parallel metallic plates that are connected to high tension DC power source such that to produce a uniform electric field vertically downward direction, and an atomizer with metallic nozzle containing eatable oil so that small negatively charged oil drops can be sprayed and allowed to fall downward between the plates. He used microscope to see the drops, but now we modified it with the help of webcam or the high quality camera is connected to see the motion of the droplets, and its magnified views is displayed on the screen. Area through which drops are falling, that is between the electrodes, is illuminated by visible light so that we can see what's going on, that is the bright oil drops. So this is the basic layout of the experimental setup. So here is the atomizer, droplets, and while passing this oil from this nozzle, they get, due to friction, they get charged with the negative charged, and the oils are probability of some oil drops to pass through this small opening between in the top plate, which is connected to positive of the high tension DC supply, and the bottom plate is connected to negative, and the separation between these plates is around approximately 5 millimeter, and uniform electric field is maintained, and a microscope is, and the webcam or the high quality camera is focused in this region, and this region is illuminated by visible source of light, and the charged droplets which are passing, charged oil droplets or drops which are passing through this narrow opening are moving with the uniform velocity. That velocity is called terminal velocity, and their motion has been recorded. Similarly, there is a modification in this experiment as suggested by Millikan, and he used X-rays in to fall on this region, and the X-rays ionize the air or the gas present between the plates, and as a result electrons of the ionized gas get attracted towards the oil drops. Due to electrophilic nature of the oil, they attract more electrons, get an highly charged, and due to the electric field, the oil droplets feel the upward force, and due to its mass they feel gravity, and that is its weight is acting downward. So basically there are these two major forces, and third force is, that is viscous force. This is known as frictional force, which is acting in the opposite direction of its motion. So when the drop is falling downward, the frictional force or the viscous force is acting upward, and if due to electric field and a high value of the voltage applied between the plates, and drop experience upward net force, then the frictional force is acting in the downward direction. And the fourth force is the buoyancy. So due to the difference in the density of the air and oil drop, so they also feel some and buoyant force. So all the forces are included, and do their algebra and to calculate the radius of the drop, and this is the magnified view. So let us explain And this is the simulation that we have designed or made with the help of GW Basic. We have tried to explain each and every component of the simulation so that any student or teacher can tell their students how this experiment is performed, as in the physical experiment only one can see what is going on inside the microscope, so but we can't show everything on the screen, so without the help of webcam. So although this experiment is very lengthy and time consuming, so in order to make it interactive and useful and to include in the syllabus, we used to describe it in the form of a demonstration or simulation. So I want to explain every apparatus on the screen. So this is the parallel plates, and this is potential. So the brief description of about the experimental setup. So parallel plates, upper plate is connected to the positive and lower bottom plate is connected to the negative of the high tension voltage, and there is a window which is in black color, because when we see through this window, and the background should be black so that we can clearly see the drops passing through it. Similarly, there is an atomizer as I explained earlier, and there is a source of X-rays which ionize the gas or the air between these plates. And the potential difference between these two plates, that is upper plate and lower plate, can be recorded with the help of voltmeter, and this is the digital voltmeter which displays the reading of the voltage. So adjust the positive potential of the upper plate so that the negatively charged oil drops comes to rest. So our final aim is to make the drop at rest. When the downward force is greater, the drop moving in the downward direction. When the upward force is higher, then it starts in the upward direction. It is very difficult to make it stable. So we make it stable and then switch off the potential difference. Then it starts moving with the uniform terminal velocity, and its velocity can be calculated from this graduated scale. So you see on the screen that the drop is moving upward and downward, and the digital voltmeter automatically adjusts the stopping voltage and time taken to cover the distance. 4 millimeter is calculated, and that is 10 seconds, and within 10 seconds or 9 seconds it is adjusted, and voltage is counted, that is 720. Sometime its value is higher or lesser depending on the charge. In this case, so all the voltages have, in this case stopping voltage is 2880. Now when we press enter, so it go to the next screen. So after pressing the enter, so all the values are displayed on the screen, like the density of the oil, distance between the plates, distance moved by the drop, coefficient of viscosity on the screen. So all the units are SI units, and this is the display that we used to explain how the drop move in upward and the downward direction. So let us move further. So the formula used, and comparing this formula, we can calculate the radius of the oil drop. So the table has been written on the simulation. So in first, distance moved is same, time taken is different, radius calculation of radius is there, and the stopping potential, this is the radius of the drop, stopping potential value, and the charge on the drop. So you see all the values of the charge on the drop are the multiple of the 1.6 10 raised to minus 19 coulomb. So this is the final screen. So every time we repeat this experiment, and you get different values of the charge on the oil drop, and it automatically adjusts the voltage, and the time taken is different. This time taken is always different, and the radius is always different. And any time you repeat the experiment, you can repeat for 4 once, you can repeat twice, and 10 times, you get the different value of the stopping voltage and the charge. But this charge is always integral multiple of 1.6 10 raised to power minus 19 coulomb. So some questions regarding this simulation. How do oil drop become charged? What is the reason that the oil drop gets charged? So the reason is friction effect between the sides of the nozzle and the oil. And another variant of the experiment, the electrophilic nature of the oil drops make it charged by sticking electrons of the ionized air to the oil drop, cause it more negatively charged. So I think it is clear. So why do some droplets move upward and other move downward? The oil drops that are moving up either contains many electrons or have low mass, as the force they experience due to electric field is greater than their weight. So drops that are moving down either contains small amount of electrons or have large mass, so as their weight is larger than the electric force. Next, why some droplets stop moving? The stationary drops are in equilibrium. The electric force is equal to the weight, so both the forces get balanced. So various forces acting on the oil drop. So this figure explains, and there are two parts of this figure. Top figure represents, so this is an atomizer and this is the drop. We magnify it, and this forces acting on the drops are, in this case, drop is moving in the upward direction because the electric force is higher than its weight, and when it is moving in the upward direction, this is the buoyant force. So sum of these forces is balanced by mg and frictional force. Friction force is always in the opposite direction to its motion, and it is moving upward, it is acting downward. When the motion of the droplet is moving downward, then friction force is in upward direction. So in this case, when the oil drop is moving in the downward direction with uniform velocity, in that case the total forces acting in the upward direction are the electric force, buoyant force, and frictional force, which is called viscous force. So radius of the droplet can be calculated using this equation, Stokes law, terminal velocity, and compare it with weight, and using these substitutions and little algebra, we get the radius of the droplet, and its value comes out to be 9 under root eta v upon 2 rho oil minus rho air into g. So this is the value of radius of the droplet. So we can now substitute for r in an original equation and obtain the value of charge, that is 9 pi d upon v into under root 2 eta cube v cube upon effective density, that is rho oil minus rho air into g. So all quantities can be used to calculate the charge on the oil drop. So these are the standard values of the constant that we used in this simulation. So finding the value of E and M, how we can calculate the value of E? Divide each charge of the oil drop, and we get that it is divisible by 1.6 10 raised to power minus 19, and so we found that its ratio with all the charges on the drops is always an integer, so that indicates that the number of electrons on any drops are in integer. So the assumption is used here, that so using the assumption that the charge on all drop on all electrons is same, So it is always integral multiple of 1.6 10 raised to minus 19, and this is the number of electrons on the oil drop. So finally find the total charge on all oil drops and divide this by total number of electrons on all the oil drops. You get the same. So divide E by M, we can calculate the mass of an electron. So and a brief overview of this experiment can be summarized in this way, that R. A. Millikan performed this experiment to disprove the Einstein's explanation about the photoelectric effect. But finally, this experiment uh, support the Einstein's photoelectric equation. So, but also it verify the quantization of charge and the charge of an electron also. So, I hope you enjoyed and learned about the Millikan oil drop experiment. If you have any query, so please comment in the bottom of this video. So thank you very much for your patience.